Okay. Okay, so today we switch gears. So I will be the interviewee. Okay, so you will be the interviewer. Okay, let's begin.
Okay, let's start. So we want to design a distributed login system for our multiple product line, because in a company, you can imagine we have like 100 products, but we want to implement a login system for centralized each product, the product login and for monitoring. Yeah.
So for metrics data, right? So my understanding is that there's application layer metrics. Also, there's like a machine level specific metrics, right? So for application layer, like how many post requests on a certain URL, right? How many concurrent requests the server dealing with? What's the latency, successful rate, failure rate, right? Like QPS, right? Also machine level, like what's the machine's memory, right? So memory, CPU or something like that, right?
Yeah.
So my understanding is those can be like a kind of like a, even though metrics tend to be schemaless, I think those metrics like can be predefined. Basically, you just need to define a key, saying like, okay, this is for method, right? Like a post method, like maybe count, or right, maybe like a latency, that's the time, right? So because in the end, we're gonna visualize those like in our like visualize this some way, right? So that means we need to be able to understand the data. All I'm saying is those kind of key metrics key is like specific. There are also another dimension, basically like a Splunk, you can search for like a correlation ID. You can search for some arbitrary string in the log. I guess that's something nice to have, but maybe not in the scope of the system. We mainly care about the metrics. And by metrics, I mean, you actually, it's kind of predefined keys somewhere, right? I mean, doesn't mean you cannot add a new metrics key. I mean, but I'm just saying, when you add the metrics key, our system knows it, right? So we're able to find it out. Okay, so I'll go under this assumption. I will not worry about arbitrary text matching, right? They're like not searching for like a specific keyword. I mean, arbitrary keyword and find it. Okay? Because
as you mentioned, we like in they have two layer. I mean, first layer is like the server side matrix. Another side is like in the application. So we can focus on application first. Yeah, and you also mentioned we can predefine some specific key. So would you type just type out what are the what a field that we can predefine?
Yeah, what I'm trying to say is okay, I just draw the gateway. Okay. Anyway, so regarding that, right? So basically, the keys you want to monitor, right? I mean, for example, we want to match so APIs. What API? I mean, so basically, when we scraping the log, right? Or our okay, let me actually draw this first. So we have, let's say we have a cluster of service, and okay, cluster of service, and you have, let's say you have 3 instances. So let's just call it the service A. So we have a multiple service, right? Service A. So this is service A. Okay, it has 3 instances, for example, right? Then you have another cluster of service. So let's call it the service B. Okay. So they all have 3 instances, for example. So basically, the service, I mean, the service is running itself, and we can have a sidecar or locally. What I mean, you can either have locally have some like a daemon process. Let me just draw a circle here, a daemon process here, or you can have a sidecar container, something like that, to extract the logs, right? So I assume the service will dump logs continuously, and if we do not need the whole log, right? I mean, just I mentioned, right? If you want to search some arbitrary keyword, we need a whole log file, right?
Yes.
Right. I mean, because you don't know which key will be hit. But if we understand something, we can probably passing the log, or the service can basically the service can somehow calculate, do some processing or passing to generate the specific data we want. For example, the data here, let's say API, let's say that means like let me try to see if I can reuse this. Doesn't let me type. Give me a sec.
Yeah, you cannot change it.
Okay. So let's say, so basically we are looking for API. What is the API? For example, let's say API, let's say mostly this is URL, right? API. It may be a whole string, like a post, because we need to know the method, right?
Yep.
API, let's say workbooks, works, for example, or tasks, for example, right? So it's generating a task. And let's say the keyword may be like count. I mean, if you use other word, we won't be able to recognize it, right? I mean, those are generated by this circle, the agent. So it's kind of like a convention. No, sorry, it's kind of a contract, right? What is being generated by the service, right?
By the way, so what's the count 3 means?
Let me try to think of another. So basically, you imagine the circle. It's outputting the data. Count 3 means like this API in this time period is has 3 hit, right?
Okay,
invoked by 3. So it's you have different way to. I mean, basically, it's your own contract, right? You define and you know the key, and then you know later how to process it, right? Yeah, but otherwise, how do you know? We maybe like, for example, another key is, let's say API, let's say get, right? API tasks, maybe with task ID, right? I mean, maybe 23, that's task ID, right? Maybe it's latency, maybe like 130. We can default the unit is time, millisecond, for example, right? If we can assume, because with this you can kind of assume like later we know how to pass it, right? Basically, it will be like a JSON data we will be sending to the aggregator. So next I'm gonna have so sorry, not this one. So next I'm gonna have a distributed queue. It could be implemented by Kafka. Let me first write it down here. Distributed queue. Okay.
Yeah. So here, why you want to use a queue?
Let me finish everything.
Okay.
So I kind of want to have a complete picture. So one thing another component that I want to have is registration service. We'll talk about it later. Registration service, and the other we want to have is a configuration service for managed configuration. Okay, config. So let's talk about this for now. So what happened is each service A, service B, say talk to the configuration service to get their interval. What I mean is, say we'll push to the distributed queue the matrix data in, let's say it's 5 seconds. So basically, let's say service A is just 5 seconds, service B is 10 seconds. Okay, depending on how you configure it. And then it talk to configure distributed queue. That means every 5 seconds, service A will push whatever. It actually batch the data in memory. It can even do some processing like aggregated count, for example. Right? If we are talking about, I mean, latency wise, we may have like a 90 percentile, 100 percentile, 50 percentile, like so latency, you might need to aggregate it for different API, right? Let's say if the API tasks called 3 times, maybe we want the average, right? Average, you mean we usually use percentile, like also we might want to also have a minimum and a maximum, like a maximum latency, minimum latency. All this data will be flashed to the distributed queue. It's kind of like a right behind the cache pattern. Okay, so I mean, you do not push it every time, right? That's gonna be too much right. So you basically push every like every 5 seconds. The distributed queue also have a multiple instance because it's so here this is login system is like append only, and every write the time series data only increase, right? And it's immutable. Once you write it, you cannot change the history of it, right? So it's basically intact. And our system need to handle the heavy write. So it's pretty much a heavy write system. And the read is, I mean, not so heavy compared to write, but maybe still to some extent it's pretty heavy to some extent, okay? But not as much heavy as the write.
Yep.
Do you agree?
Yes.
Okay.
So actually we want to audit, to audit or log in there. So that is, yeah, much more than read, yeah.
Yeah, so the distributed queue also need to have a multiple instance. If we use Kafka, you have a multiple broker. You can add more broker. So every push will be routed to the to one machine and hit some partition. Right, Kafka has some mechanism. So here, Kafka internally has a zookeeper for registration service itself. But if we have a global registration service, I mean, we can leverage that. So basically, the service A can ask registration service for the broker IP address of the distributed queue, and can even do client-side load balancing for that. Yeah, I mean, or if we do not want that, we can do a server-side load balancing. We can add a load balancer in front of the. So if we configure like a private domain name, so what I mean is the push will, I mean, either way can work, right? I mean, if you don't want another layer of load balancing, you save some machines, right? So this rectangle here is additional layer of machine because you have to do the proxy and the load balancing. So if you don't want to waste that, right? I'm just saying if we directly do the client side load balancing, so if the client know, the client will ask the registration service, okay, what's the IP address of the IP address list of the distributed queue of the queue, right? So let's say it has 10 broker, so it will have some mechanism to calculate. So you can do like a client side load balancing, so you can get rid of the load balancer here, the box here. But we can also use that to do load balancing here, right? Use a load balancer, small load balancer in front of the distributed queue for load balancer. Either way can work, right? Okay. I mean, okay. I mean, because if you take like a the in-house Kafka, you cannot separate out just in case, right? Okay. So now down we come down to the storage. So actually, so we are doing a push pattern here. We pretty much are doing a push. The trade-off here, why I choose push is that so for the pull, if we are compare first as a pull, right? By pull I mean if the distributed queue to pull every instance, right? So that if that need to happen, the queue needs to know all the instance. Definitely we have the registration service to help, right? So that's not a big deal. So first the queue has to know where those instances is. It can ask the registration service for it. So that's not a big problem. Also, the problem is each instance may have their own configuration, right? I mean, if we let the instance expose an endpoint for the buffering the data, like let's say buffer like 5 seconds of data, right? The distributed queue try to pull may be blocked by firewall or other network setting. So it might not be able to directly curate. And then another thing is if this instance went down, if let's say this machine, let's say, give me a second. So is this, okay, let's say this machine went down. Then if this machine went down, then we actually, when you try to pull it, you don't have the data, right? You actually lost it. You lost the data. That's okay because the machine went down, you don't have data, right? If we are doing a push, if we have multiple instance, since we have load balancing, right? So if one broker goes down, it still can be aggregated because you will just be routed to another machine. We still have it, right?
Mm-hmm.
So either way, I think so in this part is the same. Let me think. If you do a pull, I mean, if you do a push, you don't have a problem of data loss, right? Because
one question here.
Mhm.
So if the service A have instance is crash, right? So
Yeah.
you cannot push to the queue, right?
It cannot push to the queue. Yes.
Yeah. So that will cause some like data loss, right?
Yeah, but if your machine is down, you don't have the metrics data anywhere, right?
Yes.
Yeah.
Yes.
So yeah, you
And
don't.
you also mentioned you have like some cache in the server VM, maybe 5 seconds, or you will do the batch update to the queue, right? So maybe, but I think for the logging system, it's not big deal for us. Yeah.
Yeah, because my pushing mechanism is have this sharding and have this round load balancing. If you only have a single instance, like a dedicated, because let me draw more. So this distributed system, distributed queue have multiple instances, right? I mean, we are not saying like this push. I mean, if we are associating one instance for maybe one instance, if this goes down, and if this goes down, and basically it try to push to the same machine, we might lose the data, right? But if we can have failover to accommodate that, basically, it's just that if we have a mechanism to pair. What I mean is if you define key when routing like for a specific machine, if for specific machine we use the hash key to do routing,
Yes.
yeah, if we stick, if the machine happen to be go down, right, at one time we may lose the data, but we can quickly adjust. If we detect this machine went down, like this box goes down, we can quickly adjust the consistent hashing. If we, if we use consistent hashing, we can quickly adjust it, right? We can route it to a different machine, but we still have that kind of loss. Or if the push or I mean, if also to accommodate that, I mean, the instance can also basically do a retry if you didn't get acknowledged from the push, right? I mean, basically a push timeout, and it can do a retry. So next time it will be routed to another machine. Okay, so that's how you handle it. Okay, so next I want to talk about the persistence, how we persist the matrix data.
Yep.
So I assume, so basically we are building a time series data. So assume we have a worker, a bunch of workers. Basically we're doing pub sub, right? So basically service A, service B, they are doing publish, and here those servers are doing subscribe, okay? Here we can break it down to consumer groups. That's a concept in Kafka. Basically, what I'm trying to say is in Kafka, how it works is it basically streaming the data in the disk, right? And the different consumer group will read using their own read offset. I mean, same even for the same data. Let's say here the last one is reading the slowest, right? Assuming the data is like growing in this direction, okay? So the first instance read actually here, already here, and they are in the different offset, right? Okay, so they can read the data for them by their own pace, and the same data will be read 3 times because I have 3 consumer group, right? So different consumer group can have different database for their own purpose. What I mean is, let's say this consumer group have one database, this another one, and this is another one. Okay, let's give some text, call it DB. So they are different DB, okay, for their own purpose. Let's say, I mean, for each box here, I mean, the consumer group, you can have a multiple instance, right? For the same consumer group, only one instance will receive the message, right? Like here, I have 3 instances, only one of them will take a message and process it and stream to database, okay? Yes, that will go to database.
So
So
what database you want to prefer to store this data? Like
yeah.
you have
So
yeah.
here we can extend to different scenario. Let's say if we want to have alerting.
Okay.
For alerting, probably you generate an alert, you either send an email or you kind of some kind of like a alerting mechanism, or even to your phone. And I mean, and also like I think the most common case we want to do is basically generate like a database, generate like a what would I say for visualize the metrics, right, data, right. So that's another kind of database. And maybe even though I mentioned that we don't want to do that, even you can do like a arbitrary like a full text search, right? I mean, SADCROW probably you have to use Elasticsearch, something like that for this purpose. Yeah, Elasticsearch. And here we can talk about this later. This is more like a time series data. I'll focus on that later, right? And this for alerting, we probably can just do a relational database such as PostgreSQL because the data is not huge. I can not imagine we have many alerts, too many alerts, right? So it won't be too much, right? But if we do have this alert consumer group, probably just look at the incoming data and has a threshold mechanism like let's say the error rate is beyond like 1,000 or something, 1,000 too much, maybe 100 QPS account per 5 seconds, something like that. It will generate a alert and store it in the database, right? And store the details in the database, necessary detail for correlation and stuff, right? So that's for different purpose. So it can use a relational database. Okay, I think most the challenges for the time series database because I mean, the alert system doesn't have too much write traffic, but the metrics data itself can be a lot of very heavy in the traffic. Okay, so I want to expand on more on it. I will use a new page. Can you see the new page?
Yes.
Okay. Assume we have a timeline. Okay, now this one. Assume we have a timeline here. So let's say first our time series database have multiple instances. So they can have some kind of partition. So let's say I use 3 machines, for example. So those machines have disk and also have memory. Okay. So let's say we have 3 machines. We will use sharding by timestamp, like epoch time, plus the timestamp, plus the matrix key. Right? I mentioned that the key is like API, something like that, right? Value is like its count or its latency, right? Okay. So the reasoning for using this combination is if we only use timestamp, we'll always write to the same machine. So it becomes a hotspot, right? If we use matrix key, is there a chance that some matrix key is extremely popular, so that will also make one machine very hot, right? So I try to randomize the distribution, so each shard have an equal load, right? So this way. So once a request come in for the write, also I mentioned that this write is a batch, right? So it's basically a batch call of the so it has some aggregation and even for the same batch call, I mean, it could be a JSON load of like, let's say 10 record, right? So it actually, for 10 record, it's 10 writes because we don't know if it's hitting the same. We can do some kind of like aggregation because let's say, let me go back. Can you go back to, we can go back to the first page. Can you see it, right?
Yep.
Because this thing here, it actually, it can collect multiple message, right? It can collect data from service A and from service B and from service C, right? And then it will, so each service have a batch of data, right? Let's say service A generated 100 record in, let's say 100 record in 5 seconds, and the service B generated 200 data record in 5 seconds. So as I mentioned, right, because we are partitioned by the timestamp and the matrix key. So basically, when this machine talks to the database, it need to kind of like batch the data in a different way, right? Because the original batching is by the service, right? Because the service is sending a batch at a time to the message queue. Yeah. And here we are aggregating also data, and we want to batch it by the timestamp plus the matrix key. For example, maybe 150 is routed to this machine, and another 150 is routed to this machine. You can see the difference, right?
So why they is two of them is same? Why they go to different shadow?
Yeah, if you go back, right, service B generated a 200 record, and service A generated 100 record. But doesn't mean this 100 record need to go to the same partition in database, right? Because in database we are sharding by timestamp plus matrix key, right?
Oh, you mean the volume, like 115, like
first, my first point is we still want to leverage batching. We don't want to write to a partition 150 times, right? So we still want to flush down the whole 150 record to the database, one of the shard in one call, not a 150 call, right?
Yep, makes sense.
But we need to make sure this 150 record is supposed to be outside the machine, right?
Yeah.
Because we are sharding on the timestamp and the matrix key. I'm just saying they are different. So we have some kind of like a re-aggregation here in here, right? Okay, so that's my point. Okay, once we hit a particular shard, so I'm drawing this horizontal line here. So every machine has its memory, right? So every machine has its memory. So we will store the most recent data in memory. We can call it something like in memory, okay? In memory block, okay? So we do this machine do not flush down to the disk immediately, okay? Well, I'll talk about this later. So as time goes by, we'll generate this block will be flushed down to as a block, like a file in the disk. As I mentioned, it's immutable, right? So it's block one, let me draw it. So as time goes by, we flush down another block and another block, right? Let me call it block 2, block 3, okay? So as time goes by, I'm drawing a vertical line just to see the time range is different, okay? So if we have, because all those block is immutable, and they have some like time range because we flash it every time period, right? So they basically have a time range. So we can have like together with another file, like an index file, that keep track of the timestamp, right? Index file for the timestamp, because it's also in the block is sorted by let's say T10. So also in the file itself, it's ordered by the timestamp, okay? And then assume our query. So those go back to how we're gonna query the data, right? So when you query the data, you want to hit some kind of some blocks, right? You know, and the query assume always have a start time and end time, right? We guarantee you when you send a query, you must have start time and end time. So the start time and end time will translate to the blocks. We look up the blocks corresponding index, and we know the time range. If they don't have overlapping in the timestamp, we don't have to look up the block, right? So if we determine, let's say block 1 and block 2 is have the overlap in the timestamp, we can do a binary search inside the data, right? Yeah. And also we have the in-memory block. We also want to do search on the in-memory. I mean, that's most the reason, right? I mean, when you do a query, if the time range included the most recent in-memory block, I mean, you probably can have a timestamp there as well. I mean, in-memory is much faster, so you might also hit an older one, right? Okay. So then you aggregate all the data. And also in memory, we can, because we mentioned that we have matrix keys, right? We can do a Bloom filter. So we can do a Bloom filter for in memory. Let me write it down. So the Bloom filter can store the matrix key, what we have from filter. It can store what matrix key we have. So we can avoid, so we can immediately, okay, if we are searching for, let's say if our query is from 10 a.m. to 11 a.m. and for API, let's say the API is API books, for example. Okay, so first we have a time range, and also we have a Bloom filter. Bloom filter can filter the API key. Let's say if we know this basically is to determine machines, right? If we know this machine doesn't have the API key for API books, this machine has it. We can skip the first machine, right? So it can like filter out some machines for disk hit, right? Does that make sense?
Well, 1 second here. So as you mentioned, like they have 3 block. I mean the diagram 3 box here. So is this your application?
This is 3 boxes. Each one is a machine.
Okay. So
machine.
And how about the blocks? Like in the
block
timeline?
is what is happening on one single machine. So this is what happening on one single machine.
Okay. Yeah.
How it's stored, right? It's because it's append only when the machine write file, it's append only. So this direction here is append only, right? So for disk, the spin disk is fast because it's writing in append only operation. Yeah, it keeps flashing down, right? And also, because we want to sometimes we have some kind of like a retention policy, like maybe after half a year or 1 year we don't need it. So we're because first we are generating small blocks in the beginning, right? Every time we may allocate a new disk space to aggregate. Let's say we put a merge 2 block into 1 block, right? And we can aggregate. We can even do some aggregation on the count if we know it. Like we can do even smart calculation, right? For the same API key, we can do some aggregation, like sum up the count or like calculate the percentile for this range, right? For this time range. And also we can just skip those expired for retention policy, expired block. So we can redo so we can allocate. It's kind of like garbage collection, right? You can do a compaction on it, right? So basically this is a log structure, the data storage, so to scale it, right? It's pretty fast, can handle it.
Yeah, one more question is in your three would you go next slide? Yeah. So in this diagram, they have 3 boxes in above, right? Yeah. How they determine write the data to the blocks, like block 1, 2, 3.
It's their own disk.
First write to memory block first.
Oh, okay. So first, a machine, let's say, let me draw a new thing. So a machine has its memory. Let me draw it again. So it has its memory. Let me call this memory, okay? Memory, and it's disk, right? And let me draw it, disk this way. So this is this disk, right? Okay. So what I just drawn before is the disk. Remember the lines here, this way.
Yeah, they have timeline here.
Yeah. So the in memory, let's say every 5 minutes, it flash down from the memory. So the memory is cleared, and then it generates 1 block, right? A new block. It should have old block before, right? So every 5 minutes, you keep generating new block. Yeah, that's basically how time series database works on a high level. Yeah, like the famous time series database is like InfluxDB. Yeah. So when we query, we'll query we will pass the key and the timestamp, and we will find the corresponding block, and then when we do query, then we responded with the data, right? And then the controller can. We probably should have another controller when we do query, right? So it's also through API gateway, and let's say we have an API server. Let's say we have a service for API servers, right? So the query will hit the API server, and the API server know how to talk to the database. So it will hit the database. The later is basically what we just described, right? And let me see. Yeah, I mean, that's for query. And I mentioned like if we want to do some kind of full text search, we cannot do it this way because if we do full text search, is not, I mean, I don't know if you have a time range. Even you have time range, we do not know the key, right? Because you can match any data in the log. I mean, you could be searching like a correlation ID. That's totally different strategy. Like you might want to use something like Elasticsearch. So I think that's outside the scope of the metrics data for now, right? That's actually querying, searching the logs itself, right? So that's not exactly metrics. You are basically searching the log, right?
Okay.
That's
so,
like a pacing, yeah.
How about this scenario? I assume we have a Java application, right? We have production issue someday. So in the log, if we just look at a VM log, we know, oh, they have some error, some warning right there. So how in our system, you design a system, how we retrieve that one? For example, I want to retrieve the error. Yeah.
Retrieve the error. Oh, you mean the specific error message?
Yes, if I want to search, for
yes,
example.
That's what I mentioned in the last. That's the tracing part, right?
Yes.
I mean, I'm not sure that's in the scope of the metrics data. I mean, metrics data pretty much tell you like a more like a aggregated level, like something indication of the health, like oh, too many requests, or the API request is too slow. If on top of that, sometimes like Splunk, we want to trace a single request, right? If we want to trace a single request, usually it's called distributed tracing. You trace one request. I mean, that need your whole log that pretty much need your whole logging, right? I mean, right now the metrics data doesn't have the data, right? The metrics data only have like counts, right? Latencies, those kind of data, right? We don't have particularly that kind of data. That's for different. I think if we want to handle that, we need a different queue. Probably we should even have a different queue. Now I think about it, we probably should have a different queue for streaming logs. I mean, ELK is like a industry well recognized framework for that. We probably need to stream the log files in a different way to another queue, and that queue should be used like for Elasticsearch and stuff. It should go to a separate kind of like a subsystem, because our metrics data, I mean, the way we design the schema for the DB, like how we leverage blocks and stuff. Because if you want to do some kind of query, actually I want to add to that. You can also add, for every block, you can do reverse indexing. So if you want to search for some key, because we don't have the key here. I mean, we are ordered by the timestamp, but for every timestamp, we don't know what the key it has, right? So for every block, we can have a corresponding revert to the index for searching purpose. But that being said, this is still relative to the API key, right? We do not have as data, like you said, what kind of error message it is. We don't know actually, right? So because we didn't store the whole log, right? Like error message itself. So that if we want that, suppose that it's a different system, a subsystem we can leverage, but it should be similar. You can still push to another queue. We don't want to use the same queue because the data is different, right? And probably a different topic in Kafka, and you have a different consumer group just handling that. And yeah, I mean, that will have some kind of like a latency, right? Definitely that would have some latency, not going to be a real time, because if you leverage like Elasticsearch for indexing, it have some latencies. Yeah.
Awesome.
Yeah. 啊，你觉得差不多了吧？
哇，你这个内容好丰富，好丰富。
对，这个就是一个比较完整的一个系统设计了，就是说啊，行云流水的答的吧，反正就是基本上能讲都讲了。对你就是，
其实我到后面我有点我其实有点就 time series data 那个，其实我也没那么。
因为你对 DB 不太了解，我听出来了，你对 DB 这块，上次我说这个 DB 的话，你就不太了解，对吧 ？Sharding 啊 ，replica， 不，这里还没说 replica， 其实每一个机器的话，其实它 replica 也有不同的机制吧，反正 Cassandra 就 DOVC， 对我可能忘了提那个 replica 了吧，因为你 DB 可能还有 replica 什么东西，对，这个就更深了，就是说，对，要讲 replica 其实也都大同小异，其实对我来说，就是这个 machine 存的话，这个 machine 也要存一份，基本上，对吧？就是一个 copy 嘛，对吧？ 就 follower 嘛，相当于是卡夫卡也有这个机制，就是 primary 啊 follower 啊什么的，对，好像是 lead 好像 follower 什么的，反正就是你就现在就刚才我讲的时候就存在一个 disk 上嘛，其实万一这个 disk 挂掉了，对不对？所以刚才我忘了讲 replica 了，就是万一这台机器挂掉了，对吧？那你需要有 replica， 对吧？反正我们如果用的是 consistent hashing 的话，我这个思路基本上 consistent hashing 的话，它默认它就是个，如果它是 consistent hashing 的话，它实际上是一个 ring， 就是说这个机器啊，就是一个 ring， 就是这台机器后面的话，就是这台机器，比如说是 primary 的话，它的 replica 在它后面，对吧？也就是说刚才那台机器上面的 disk 的东西，我们其实还要，它如果写的话，它写在一台机器上的话，它还要在后面再写到另外后面2个 replica 上去。这个可以异步发生，就是说这样。对，它包括还有 commit log 呀什么的，这个其实跟 consensus 就非常相像了，就有点打通了这个东西，就是 consistent hashing 了，就是因为我不是说用这个做 shard 嘛，对吧？做 sharding 嘛，对吧？
刚才还有一个点啊，就是说你刚才就是说150，刚才有一个 app 是100，有个是200，对不对？进去了之后，对吧？
对，你可以这么想，等等，我看啊，首先我觉得我忘了说这个 data， 我找一下啊，我看能不能找到sample， 我看bit 好 sorry， 我搜一下一个以前比较著名的一个，你知道 Spring Cloud 有一个叫那个 Spring Cloud 有一个叫那个 Histrix 的那个这么一个，就是它就是 open， 因为他们其实都是 pool， 但我这边选择 push， 对吧？就包括普罗米修斯，它也或者我拿普罗米修斯吧，这几个框架你不知道吗？
我听你那个讲的，但是我自己其实
这个业界比较，它实际上是 endpoint， 我实际上想让你看一下它的 JSON data 大概长什么样的，我看能不能贴一下啊。因为你可能对这个 data 本身不太了解，所以有这个困惑。我现在就是一时找不到那个好的那个 JSON 的它那个 data API endpoint，我想给你看一个 sample 嘛，就是它那种 data 长什么样。我看这个行不行啊？我 share 一下，我看我能不能 share 另外一个东西，稍等啊。stop share and 我 share， 看能不能 share 一个 browser。我操，我看窗口太多了。我看一下我想 share 我的 browser 在哪儿？Source tree， 我找不到我的 browser， 找到了，看得到吧？这个有点竖着，我把它拉大一点，看到吗？
可以看到。
对，它长这样，对吧？我在搜这个东西，它就是说这是它的这是它的普罗米修斯的 API， 然后的话，你看你如果 curl， 你看啊 curate， 因为它是属于 pool 的，等于说是给它个时间，对吧？就是现在然后 curate， 然后这里有 data 里面，比如说 matrix， 我看它有啥呀？up， 这个感觉这个不太好，我看看有没有好一点的数据啊？values 这是啥呀？这个 query metadata，看一下啊，我要找个比较 meaningful 的几个 data 啊，什么？他感觉这个都在 query 它那个本身这个东西，这个不是那个 magic data itself， 这感觉更像是那个他那个普罗米修斯的自己的数据吧？我想想看啊，我得找一个 Prometheus matrix data 有没有比较好的啊？这个其实我刚刚举的例子就是吧，但是你看它这里的话，你看 total， 你看这是 total 对吧？比如 method post、handler messages 啊什么东西的，这个好像是发给那个 matrix type， 你看它这里有 counter gauge， 找不到例子，一时半会没找到例子，等等我看能不能再找一下。你继续说你的问题啊。
我刚才讲就是说有一个点，就是说你刚才说product 1产生了
你看这数据呢？你看，这是一个 sample 数据，你看到没有
？matrix
你看它有，你看得见吗？
看得见 duration，
你看它是 bucket 的，比如 get 这个 pass 它都是一样的。这里看0.005、0.001，这个可能是 percentile， 我不是很确定啊。le 是less than 我大概知道了。这 get 这个 pass 是指你的 API 的 pass 就是刚才我们说的 URL， 其实是 method pass，刚刚跟我们这个差不多，对吧？名字不太一样，对吧？这个 LE 应该是 less than or equal to 这个0.0050个，然后 less than equal to 一个的话有一个 less than 2.5的话有一个，就是对，就是说就是数字吧，这里应该是 bucket，然后这里有 count，对吧？这个数据那给你一个 sense，但是我感觉它数据不是特别，我看这个有没有更好一点啊？你看 status 等于500的有多少个？你看到没有？这个 console， 你看这就是他们的那个，这是它的数据，当然不是 visualize， 把它 visualize 以后就变这样。就如果你用过的话，实际上你可以去看一下，如果你用过，实际上 Prometheus 你搭过或者 Histrix 你搭过的话，这个数据大概长这样的。就它是一个，你现在这个已经是给你一行一行写好的，它实际上是个 JSON 的数据，对吧？就是一个 key value 一个 key value 这样，对吧？对，你可以想象，然后它这里其实这个已经是 aggregate 的 count 了，对吧？404的有几个，500的有几个，对不对？是吧？看到没有 ？Method 的，可能你还有 service instance 吧，因为你可能要别的数据，对吧？instance 你看 instance 是谁，对不对？是吧？或者还有别的 key，对不对？是吧？你可能还有这个机器是哪个机器你也得知道呀，对不对？是吧？对。instance 啊，然后job 可能这个 job 就根据这是你 business 逻辑了，对吧？method 一般有的，对吧？pass 也一般有的 ，status 对不对？是吧？啊，然后这个是 count 啦。那还有一种的话就是那种时间，就是比如你这个 API call 花了多少时间，对不对？是吧？就他这边就是最后 query 的时候，他得能够 understand 它，对吧？就不是你任意写的，对吧？就算你这边要加新的东西，比如说你加 instance 没关系，反正这个我知道 instance。就这里的 instance 啊、job 啊、method 啊，或者 status 啊，或者是 latency 啊，这种 keyword 它必须得认识，对不对？是吧？当然，这个 value 的话，就是它需要 pass 的，对不对？是吧？这 alert 它也做，对不对？是吧？我这个也算是个比较好的 example 吧。啊，你问问题吧。
对，刚才你这个图，回到刚才那个图啊，就是你画的那个图。
是我画的吗？
对，
我那个白板你没了。
那没事，反正就是有一个 product 是100个 batch 过来的，还有一个是200个 batch 过来的。
对。
然后你说那个150那个我不太懂。
你这么想啊，比如我们看刚才这个数据，对不对？是吧？在这儿，好，比如说啊，这个是 instance，比如说是 localhost 8081的，它是
对
100，对不对？100个，对不对？是吧？
对。
instance 等于 localhost 8082的是200个，那么加起来是300个，对不对？是吧？
对。
但是这300个里面多少的数据是去，我们现在讲存储啊，多少个数据是去那个 shard1，多少个数据去 shard2啊？那是由什么决定的？是由这个 pass 对不对？和这个 timestamp 决定的，是不是？
因为你把那个作为它的 sharding key 嘛。
对呀，是吧？如果是个 range 的话，我可能就是 begin time，因为它可能是每5秒，我可能拿它 begin time。就是说，也就是说，这300个 record 不是这300个全都去一台机器上的，对不对？是吧？因为我们不，因为他们之所以是100和200，他们是某种意义上是根据 instance 在分，对不对？是吧？它先开始这300个东西是根据 instance 在切，对不对？是吧？
对。
现在我不根据 instance 切了，我要根据它的 pass，甚至 pass 加 method，我觉得 pass 加 method 再加那个什么，比如说 timestamp，对吧？是吧？去做 sharding，对不对？是吧
？OK，那
吧？
你的意思就是说，把它的 sharding key 是同样的东西挪到一个上去，是吧？挪到一个 sharding，
你总归得提供一个 key 来做 sharding 吧？
对。
你总归得提供一个 key 做 sharding，因为好处就是说到时候，比如说我要搜，比如说我回头我要 query 的时候，我要 query get，比如说 API full，那我基本上我能够 hit 到同一个怎么说呢？我想想看啊，你不一定会 hit 到同一个 shard，但是呢，就是说在同一个 shard 里面呢，他们怎么说呢？就是说
时间期或者说那些 sharding key 很接近的都放在一起嘛，对不对？
某种意义上 grouping 吧，就其实还是挺 random 的，就是说，但是至少你如果给你一个具体的，比如说某一个时间、某一个 begin time 和某一个 API pass，我至少知道它是去哪台 machine 的，对不对？如果你要搜那样的数据的话，当然我们不一定有那样的 query 啊，是吧？对，因为现在就给你一个 pass，你是不知道去哪台机器的；给你一个 timestamp，你是不知道去哪台机器的。但是如果我知道 pass 加 timestamp， 我知道是哪台机器，对不对？是吧？ 某种意义上是可以知道的，对吧？是吧？
就是说你就是说刚才是业务，就是不同的机器来的是按那样分的 group 的。
我们做 sharding 的话，一个是想避免 hotspot，就避免所有的数据写到一个机器上，对吧？那一个呢，就是为 query 服务，就是我们 query 的时候啊，我们尽量能够 leverage 这个就是说 route 到某一个固定的机，就是我们知道哪台机上去拿，对不对？是吧？如果你完全 random 的话，我们就全拿。就假如说你有100台机器做 DB，对不对？那假如说你是完全 random 的，也不是不行，对不对？那等于说我每次都得调这100台机器嘛，对不对？是吧？
就是 retrieval 的时候你就好拿，就快了一点，知道
retrieval 你可以一定程度上 filter out 一点。我后来不是还加了 broom filter 嘛，也是为了进一步。
那个我不太懂。
broom filter 你可能不知道这概念，你回去查一下吧。我们什么是 broom filter？我以前也讲过，好吧 ？broom filter 是一个简单的那个 space efficient 的一个等于说是个 bit factor，它可能有 false positive，就是有可能他觉得是有，实际上是没有的。但是如果他觉得没有的话，那肯定是没有的。就如果他说他如果说这个机器上没有 API 负，那就肯定没有，你完全可以 skip，好吧？大概是也是为了避免，就是回过头来就是说，如果你有100台机器，你不想每次search的时候都去 hit 100台机器吧？
对，
是不是？
就是你就快速的判定一下那个地方没有就不要走了，是吧？
至少比如说，如果我收一个 range，比如10点到11点，对不对？那我可以根据 begin time，我可以换算成10.05、10.06、10.07、10.08，然后我再加上，因为你肯定有个 API key 嘛，对不对？是吧？然后我把这些加在一起，我算一下哪些 shard 是不用 hit 的，对不对？
明白。
我可以快速的就是 filter 一下，哪个 shard 是绝对不可能有的，对不对？是吧？因为我们假如说我们是每5秒的话，假如说我们是按照 on the clock，比如说假如是5秒，对吧？那基本上我们可以 on the clock，我们用那个 begin time 做 sharding 吧，不用 end time，对吧？是吧？那基本上你知道你的数据大概是在哪些 shard 上面，对不对？是吧？就算你是个 range，你也知道你的 range 无非就是 collection of 那些 begin time 嘛，对吧？是吧？就这个意思。就也就是说，我们在 dump 到 database 之前，我们那个机器还是做了一些 pre-processing， 对不对？一个呢，它肯定要 aggregate 到具体的那个时间，对不对？是吧？明白吧？它肯定也要按照几秒算的嘛。比如说0秒到5秒，然后是5秒到10秒，对吧？其实是6秒到10秒了，然后是反正大于5秒到10秒，然后大于10秒到11秒，对吧？大于10秒到15秒，对吧？是吧？
就把那小撮都，
因为你先开始过来的是按照 instance 在做 partition 的，等于说是吧？
然后你按照时间切嘛，就是
对，你按照时间加 API
加上加上切，对吧？
对，你写的时候你知道写到哪个 partition 里面嘛？然后比如说我们有150个是滑到 partition 1的，有150个滑到 partition 2的，那你就发2个 batch call 嘛，对吧？因为你是一下子把这150个全部 dump 过去的嘛。
那这一块，比如说你这个下令你已经给他一个 key 了，那这个具体这个计算是在那个他自己的那个地方做 database 层面自己做的是吧？还是我们手动就是在程序里面做的
？sharding 如果你用 consistent hashing 再加那个 registration service， 你就能够判断你总共有多少个实例，对不对？是不是？
对。
那就直接通过 consistent hashing 做就可以了，不需要，就是个 hash ring 嘛，就根据那个 hash code 用 consistent hashing 那个算法一判断就行了。你可以做 client side 的那个 load balancing， 因为你可以从 registration service 里面去拿你这个 IP address list 嘛，然后你用 consistent hashing 一算就知道你应该去哪儿了嘛。其实，在 Cassandra 里面这个叫 token aware client， 这个实际上就叫做 token aware。你的意思，我怎么知道 hit 哪个，对吧 ？hit 哪个机器是不是吧？
对，我就想这一块任务其实是在哪一块去做的？就是在 database 层面做的呢？自己
不是 database 层面，就是你那个 worker， 就是你的 consumer 就可以做。
因为我看那个，比如说 MongoDB， 它假设 Mongo，
对，这个可以在 database 层面做这个事儿，那你不就多一批机器嘛，对不对？等于说就这么说吧，你相当于在前面这个机器交给你，你自己做 load balancing 嘛，这无非就是 server side load balancing。什么叫 server side load balancing 啊？就是你又提供一批 server 来做 server side load balancing。我不知道你这样讲明白吗？就是我不知道能不能画一下，就是说我看能不能 annotate， 好像做不了。那我停止 share， 我在 new share 吧，我在 stop share 好吧，然后我再 share 一个新的那个 whiteboard。
因为我看 Mongo 它旁边有一个，
我知道你的意思。这个又回来，这个又有了哈。我怎么找？你能看得到我这个 whiteboard 是吧？但是我好像画不了，我看不了新的页了。有可以啊，我们开一个新的页吧啊，就是这个意思，就是说无非就这是你的 client， 比如说是吧？
对呀。
你有多个 shard 对不对？下的
对
下的1、2、3对不对？是吧？那么 server side 的 client load balancer 就你还要加一批 server， 就你 client 把请求发给这个 server， 这里也是多个机器，比如说是吧？然后这个 server 呢再给你 route 到某一个 shard 上。
对，
这一块就整个就是 MongoDB 自己管了，对不对？是不是？
对，
这个就比较 self-contained 嘛，对不对？是不是？但是坏处就是说你又多了一批机器做 routing 嘛，等于说是不是？对不对？那假如说我的意思就是说，你可以做成 token aware， 什么意思？就这个就不需要了，就直接 client side 就直接判断，直接 client side 做这个事儿了，就是说就可以省一批机器嘛。
这样啊？
当然可以，这叫 client side load balancing， 这个自己去复习一下概念嘛，什么叫 client side load balancing， 对不对？刚才这种是 server side load balancing 嘛，对不对？是不是？其实就是说就是说穿了就是 routing 的逻辑是哪层做嘛，对不对？是不是？
明白。
你如果 server side load balancing 相当于把 routing 的逻辑交给中间这层 cluster 去 handle 了嘛，对不对？是吧？那么这个就占用资源嘛，也是，对吧？在 Spring Cloud 里面，所以每一个微服务前面都有个小的 load balancer。就假如说这是一个服务，里面有2个实例，它前面就有给你起一个小的 load balancer。那坏的处的话，这个 load balancer 也占资源嘛，对不对？是吧？对吧？那么如果你改成 client side load balancing 的话，通过 registration service discovery 做 client side load balancing， 你可以省掉这个 load balancer 嘛，对不对？是吧？因为那个registration service 它实际上它有 consensus algorithm， 它能保证你的一致。就是说，就最怕就是说这个 client 比如这是 client 1，这是 client 2，就怕 client 1看到3台机器，client 2看到2台机器，那就出问题了，对不对？是吧？
client 2怎么看到2台呢？
网络啊，也许它这个网络正好没连上，每台机器不一样，这个产线里面挺多的。
明白。
网络问题啊，有可能 client 2只能看到1和2，看不到3，有可能的，是不是？
就不可能。
这个问题还挺频繁的。但是如果大家都是去问那个 registration service 的话，为什么什么叫 consensus algorithm？ 就是为了保持一致，你知道吗？所以就是说 client 1和 client 2不要直接去看，他去问那个 registration service 能保证你拿到的 view 是一致的，你知道吗？
明白。
为什么我们要设计什么 raft 或者 pixels 去做这个事儿，搞那么复杂，就是为了 consensus， 对不对？
你说他们 CEC 要拿到的东西就是 config 是一样的。
consensus 的话，就是我画一下 consensus， 你去查一下 consensus algorithm， 对。你去了解为什么有 zookeeper， 其实你要知道 zookeeper 具体为的是干嘛的，好吧？自己去复习一下，好吧？为什么要用 zookeeper？ 为什么需要 consensus， 对不对？好吧，这个面试官肯定知道，我就不跟你解释了，好吧？不知道就那个了，好吧？
不知道了，
这个就你这个得知道，你不知道的话就显得比较 low 了，好吧？
行，
那今天就讲到这儿，好，回去我上传一下啊，
拜拜。
好，拜拜。